was an incredibly gracious introduction. Oop. Thank you, Sarah. That was an incredibly gracious introduction. And just for the audience, Sarah has been one of my absolute favorite colleagues at Deloitte. She exemplifies the reason why I love working in consulting. Sarah, your enthusiasm, intelligence, and interdisciplinary mindset is just fantastic. And I think what we need more of in the field of AI, which is what I'm going to talk about today. So let me share my screen. As Sarah mentioned, I've been a data scientist for 20 years. I had this title, Chief Data Scientist, which was Deloitte's kind of polite euphemism for oldest surviving data scientist. I mean, I started this so long ago that the term data science didn't even exist yet. A lot of people think it was invented in Silicon Valley in the late 90s. It actually came out of Bell Labs in 2001 by proteges of John Tukey, the guy who pioneered data science. At any rate, a lot of this stuff is now being framed. A lot of what I've done for the last 20 years is being framed as artificial intelligence. And I used to think about artificial intelligence occasionally when I was doing data science. I'd kind of think about, okay, when I'm trying to do machine learning to help me select variables for an algorithm, I kind of thought about, gee, that's kind of automation. And like, when would we get, what parts of this, that what I'm doing can be automated? What parts, do we really need me for? And it occurred to me that choosing the data set and doing that intelligently and figuring out like what to optimize with an algorithm, solving that is equivalent to solving the general AI problem. And so now that there's all this kind of like loose talk about AI, and being in consulting, this kind of like literally affects my career and my, kind of way I function in the business world. I got kind of obsessed about what AI is and how does it relate to data science. And along the way, as Sarah might alluded, I became very interested in behavioral science. I'll make a few comments along the way about kind of the science of judgment decision making is a way of understanding the work I was doing in predictive analytics at Deloitte. And then later on along the way, I got very interested in the nudge playbook and this idea of can we fold the nudge playbook in is a toolkit for a field that I might call greater data science instead of narrow data science. Again, I'll say some words about this along the way. All right, so anyway, AI, everybody's talking about AI right now. AI is the new electricity. Someone I know here at Stanford is just getting his PhD in sociology and computer science. And he said that all the kids at Stanford now are kind of rolling their eyes when they hear this kind of stuff. It's like some of the hype is beginning to dissipate. But actually, I think this is a serious quote. I think that when Andrew Ng says AI is the new electricity, what he's telegraphing is this idea that AI is a general purpose technology, which is defined to be a technology that's expected to have both wide-ranging and more or less permanent impacts on the economy and societal arrangements. So previous examples of general purpose technologies were the steam engine, the railroad, the internet, mainframe computers, and of course, electricity. So I think that's a reasonable statement, even though it might, kind of like lead people to, overinterpret. At the same time, AI has also been called an intellectual wild card. So Michael Jordan is not that Michael Jordan, the machine learning guru, Michael Jordan at UC Berkeley, very distinguished machine learning researcher and expert. He says that, too often we use this as an intellectual wild card, and that makes it hard to reason about the scope and consequences of the emerging technology. Orwell said that sloppy language makes it easy to have sloppy thoughts. And I think that kind of happens here too. And he said something very interesting. It's not just this classical case of the public not understanding the scientists, like maybe with COVID vaccines or something. Here, the scientists are as befuddled as the public. I think, again, because it's kind of like a very loose tagline-y kind of word. And a couple of weeks ago, Jerome Lanier and Glenn Weil at Microsoft Research, of course, Jerome Lanier is this great pioneer of virtual reality and a philosopher. They came out and just said, AI is not a technology, it's an ideology. The technology is really applied machine learning, and AI is just kind of like ideology wrapped around to this kind of their point. And I think I've been saying something kind of consistent over the years. I talk about what I call the master narrative. This is an allusion to a book by Pedro Domingos called The Master Algorithm. AI started, in fact, the term AI was coined by a guy here at Stanford, John McCarthy, founded the Stanford AI Lab. And he gathered some of the brightest minds of the day. Marvin Minsky was his counterpart at MIT. Claude Shannon, he had the office next door to me, actually, back in 1958, 2 years after the Dartmouth Conference. Inventor of information theory. Herb Simon, the kind of proto-behavioral economist, Nobel Prize winner, kind of forerunner of Daniel Kahneman and Amos Tversky. They were all there at the Dartmouth AI conference. And these guys thought that it would be possible to essentially implement human-style cognition in machine form, and they thought they could do it within a generation. They said every aspect of learning, any other feature of intelligence could be so precisely described that a machine could be made to simulate it. It's no accident that Marvin Minsky went on to advise Stanley Kubrick when Kubrick made the movie 2001, because these guys thought that you could have kind of sentient machines, sort of like the HAL computer from 2001, by 2001, they were sort of breathing a philosophical air at the time that made that a natural assumption to make. People thought, that the world was made of logical atoms. We could, in principle, create a language that kind of like was about, thought was like a kind of calculation involving these symbols that represent those logical facts in the world. Well, that sounds like software, and we've got computers. So, there you go. Turned out it's not so simple. That idea was actually kind of going out the door in philosophy right at the same time they embraced it. So it's kind of historical irony. But that's kind of where it came from. And it's never gone away, because now every time there's a big breakthrough in machine learning, it's framed as another step along this path to general AI. So 20 years ago, when Gary Kasparov was beaten by IBM's Deep Blue, it was kind of discussed as being the brain's last stand. After all, if you can get a computer to do something as difficult as playing chess, what can it not do, right? 8 years ago, Brad Rutter and Ken Jennings were beaten by IBM Watson on Jeopardy. It's taking a minute to remember the great Alex Trebek. And Ken Jennings joked, I for one welcome my new computer overlords. And then a few years after that, Lee Sedol was beaten by AlphaGo. And the New York Times quoted a business school professor at a very prominent business school who said, Google's AlphaGo is demonstrating for the first time that machines can truly learn and think in a human way, right? That's kind of like what these guys were saying in Dartmouth, 50 years earlier. 60 years earlier. And then, so therefore, it's natural to assume that these machines are becoming so smart that they can essentially, they're going to get to the point where they can take half of our jobs. There's that Fry and Osborne report from Oxford, maybe 7 years ago. And, maybe we don't have to worry about that, because maybe these computers are going to become so intelligent that they'll essentially become a master race and just kind of take over. So people like Nick Bostrom, Elon Musk, there's a lot of very influential and very well-funded people who go around saying that we're going to have an intelligence explosion, and these computers will become like a master race. And again, that's telegraphing the original kind of ideas of those thinkers at Dartmouth 60 years ago. Someone once asked Marvin Minsky, "Aren't you concerned about computers becoming a master race?" And Minsky replied, "Well, no, not really. I mean, I'm superior to my pet, and I take care of my dog. I treat my dog nicely, and the computers will take care of us the way I take care of my dog." And like, really? Is that really what we want to spend all of our time and money building, is a technology like that, even if it were possible? That's kind of interesting. So that's the master narrative. And, I'm making a little light of it, but it has serious impacts. So a couple of years ago at Davos, in public, a lot of the, kind of captains of industry are saying, we want human-centered AI. We want AI that's going to extend people's capabilities. But behind closed doors, they're saying, hey, when are we going to have computers that are smart enough to replace 90% of my workforce? It's kind of what people want to do, is replace humans with machines. It's not just the business leaders, even the scientists themselves. So Jeff Hinton is one of the great heroes of this field, right? He kind of like kept deep learning and artificial neural networks research alive during these dark winter periods. So, he's a really important scientist. He said, we should stop training radiologists. It's getting to the point where we have deep learning algorithms that can like flag cancerous tumors and medical scans better than the human eye can. So it's just completely clear we should stop training radiologists. Now, just think to yourself, does pattern recognition really sum up everything that a professional radiologist does? Or maybe a better question is, does pattern recognition really sum up everything that a professional radiologist could or should do, given the availability of these kinds of algorithms? Maybe there's a much more interesting role for radiologists, and a very vital role going forward. And actually, Eric Topol has written about that in the book Deep Medicine. And we can talk about that during Q&A if people are interested in like the future of work, implications of all this stuff. Now, and there's an irony too, because at the same time people are talking about computers becoming so smart, they're just going to take over everything. What are we really seeing in the world? Different forms of what I call artificial stupidity. So we've got, algorithms that are biased against women in hiring situations, biased against minorities in healthcare situations, algorithms that are not as accurate at recognizing dark-skinned faces as light-skinned faces. And of course, this is Joy Buolamwini. I hope I'm pronouncing her name correctly. There's a new documentary about her that just came out called, I think, Coded Bias, which I've not yet seen, but it's available for viewing right now, I think. MIT Media Lab researcher. We've got, Tay. The chatbot Tay was actually what woke Microsoft up to the importance of AI ethics. They released this chatbot. They said the chatbot is going to become smarter as it interacts with people on the internet. Well, it became smarter in a way, but essentially it was kind of like a parrot. You can train a parrot to swear and say vulgar things. Well, Tay was trained to become a racist authoritarian chatbot within 16 hours, and they had to pull the plug on it. A GPT chatbot, powered chatbot, told a mock patient to kill him or herself. And here's another kind of form of artificial stupidity that I'm going to focus on a little bit more. A Tesla driver who killed himself because he essentially ceded some of his human autonomy to the autonomy of the vehicle when he shouldn't have, and the car crashed. And it wasn't just one case. There have been a number of cases like this. I heard about a case just the other day where someone in Silicon Valley was killed 7 seconds after he took his hand off the wheel. I just heard this on just on Tuesday, in fact. So that's a form of artificial stupidity too. You can imagine, AI and self-driving cars are really semi-autonomous vehicles that help us stay more alert. Instead, this is framed as AI that kind of takes over for the driver. And in fact, Toyota is very interesting because they actually are going along on machine learning to help people stay alert, not to replace drivers. But the ideology is it's going to become so smart and superior, we're not going to need steering wheels in cars anymore. People retweet fake news more than real news. The nudge co-author and kind of behavioral nudge pioneer Cass Sunstein. I mean, he did work with Daniel Kahneman years ago. Where people deliberating in Colorado and Boulder about an issue like gun control or abortion. They move to the left after they deliberate. People in Colorado Springs doing something similar move to the right. That's just group polarization, a psychological fact. If you think of that as being a small flame, well, if we have collaborative filtering based apps online that recommend social groups or news media or opinion pieces to people, that's going to get confirmation bias, and it's going to amplify. It's going to pour gasoline on that little flame and cause massive group polarization. And I think we're all feeling the impacts of that right now. Sinan Aral at the MIT Sloan Business School has a new book about that called The Hype Machine. And of course, we've all seen the documentaries. We all know how it's addictive, kind of like impairs our emotional regulation. So, just in terms of we want AI that helps us make smarter decisions, helps us with our behavior, and helps us be happier and healthier. And it, in fact, does the opposite. And I think what I'd like to explore, and that's kind of what I'm doing here at CASPAS, the Center for Advanced Study in Behavioral Sciences, I'd like to explore this idea. Maybe a useful organizing principle for some of this is that smart technologies are unlikely to engender smart outcomes unless they're designed properly to promote smart adoption on the part of human end users. And so the corollary is that effective and ethical AI needs some notion of human-centered design that hasn't fully been articulated yet. It hasn't fully been absorbed into the community. I think there are a lot of ideas in the air, but it hasn't been fully kind of the fact that there are so many examples of artificial stupidity that keep making the headlines kind of demonstrates that the AI community is not really kind of taking this on board yet. I'm a data scientist, and I myself remember when I started, I was completely framing my work in terms of taking a data set that someone else really prepared for me, or I had some role in preparing, but really the data that was uninteresting. I really was interested in the math. That's really what I wanted to do. I wanted to take the data set and build the coolest model and throw that model over the wall. That was really my job. So I remember what that was like. And so I can kind of empathize and identify with people who have that view, but that's a very dangerous view for society. So we need, kind of a notion, not just of narrow AI, but kind of greater AI. And where I'm going is that greater AI needs a broader conceptual scientific framework than just machine learning. I think it needs the behavioral insights toolkit. That's why I'm here. All right, so I'm talking about human-centered design, and of course, the guy who wrote the books on this was a former CASPAS fellow, Don Norman, cognitive scientist, founded one of the first cognitive science departments at UC San Diego. And actually, Jeff Hinton, the neural net pioneer, was a postdoc in his department when Norman founded that department at UC San Diego. Early on in the design of everyday things, this should resonate with you guys, you behavioral insights mavens. He wrote, "The problem with the designs of most engineers is they're too logical. We have to accept human behavior the way it is, not the way we wish it would be." An incredibly insightful comment. And the canonical example, which I guess in this crowd you're all going to be familiar with, is the Norman door, right? You walk up to this door. The affordance is that if you push it, it'll let you out. And there's even a little sign saying push. But there's a signifier that's kind of a perverse signifier. It's a pull handle. So you pull it and you feel like an idiot that you pulled it. You're thinking fast when you should have thought slow, read the instruction manual and push, but you don't. We always think fast if we can. But Norman would say, no, the guy who should feel like an idiot is the guy who designed the door, not the person who made the mistake, right? Now that's kind of a little fruit fly, trivial example, but it has big implications. Why is Apple the most valuable company in the world right now? Essentially, Steve Jobs took that idea on board. Cass Sunstein called Steve Jobs a choice architecture of world historic significance. If you've seen the movie, he had all those debates with Wozniak. Wozniak said, look, what matters is the microchips, the processing. Can we make these calculations? And Steve Jobs said, no. Computers are bicycles for the mind. They're things that can extend our capabilities, extend our intelligences. He was telegraphing ideas of Douglas Engelbart, the guy who invented the mouse. And of course, Steve Jobs famously bought the mouse from Engelbart for like $60,000 or something like that. And so if you think about the computer, it's the opposite of a Norman door. A door is a very simple technology that people use improperly. It causes artificial stupidity. I pull when I'm supposed to push. Sometimes people even get hurt in extreme cases. Whereas the computer is one of the most complicated devices that human being has ever built, but a kid can use it without an instruction manual. And Cass Sunstein says this too, the essence of good choice architecture is you can navigate a complicated choice environment without an instruction manual. I think this is Don Norman 101. And if you get it wrong, it can be equally catastrophic. So Don Norman said the control room at 3 Mile Island could not have been more confusing if they had tried. So if people were econs and not humans, if we're perfectly logical, Mr. Spock, rational actors, sure, you can push the stop button, paint it green, and people would never make the mistake. But we're humans, so you don't want to have the equivalent of Norman doors in these fraud environments. Now, these are all familiar examples, but what I think we need right now is that, by analogy, AI technologies will yield better outcomes when they're designed for the brains of humans, not econs, okay? So I'm gonna give a couple of examples like this that map roughly onto this distinction between thinking fast and thinking slow. I'm gonna speak for another 20 minutes or so, guys, and so feel free to type questions into the chat room. Sarah, is everything going okay so far?
Everything is great, thank you so much.
All right, I'll keep going. Okay, thinking fast and slow. So a couple weeks ago, or maybe a couple months ago now, a friend of mine at Deloitte, Lavan Srinarayanas, was another one of my favorite colleagues, brilliant guy. He forwarded me this article from the New York Times, which had some things that really caught my eye. The algorithm that grants freedom or takes it away. I think you guys have all read about these recidivism algorithms. They've been used for decades, right? It's now being framed as another kind of AI, right? I used to think of this as just being predictive models to help experts make decisions better. That's a better, clear way of thinking about it. But there are a lot of problems with the way these things are actually deployed. Kind of by analogy with the Norman door and 3 Mile Island. There are things that the door works, 3 Mile Island, the buttons all worked, but we had artificial stupidity. And I think something similar is happening with some of these recidivism algorithms. And I know you've all read about algorithmic bias, and that is important. It's something I want to kind of cover in the work I'm doing here at Caspis, but that's not quite what I'm going to focus on here. So there's a lot of controversy about this, and there are a lot of people, I've spoken with very, very smart people smarter than me, who think we just shouldn't even use these things, okay? So I'm not gonna completely make a judgment about this, but I'm just gonna say that I'm gonna quote Richard Burke, who's a very distinguished statistician at Penn's, UPenn's Wharton Business School Statistics Department. And he's kind of like the expert on building recidivism algorithms. I believe he's written entire books on the topic. And this article quoted Richard Burke saying, look, automatic pilot is an algorithm. We've learned that automatic pilot is more reliable than individual human pilots. You don't want just humans, flying planes by the seat of their pants. You want automatic pilot. We have, fewer accidents. And the same is going to happen here with judges making decisions. We're going to get better, more fair, consistent decisions and so on if we use algorithms, if they're kind of part of the story. Sendhil Mullainathan says something very interesting too in a different article. He said the places where people are most worried about bias, hiring, medical decisions, jurisprudence decisions, lending, insurance underwriting decisions, and so on, those places are actually the places where the algorithms have the greatest potential to reduce bias. I think Mullainathan is telegraphing a very old body of knowledge and research from psychology that you guys all know, I think, right? It goes back even before Daniel Kahneman. It goes back to Kahneman's predecessor, Paul Meehl. He's a very, very, very distinguished scientist, one of the forgotten heroes of the 20th century science, in my opinion. And he wrote this book back in 1955. Actually, yeah, in 1955, I believe, ironically, the year before the Dartmouth Conference. He wrote a book called Clinical versus Actuarial Judgment. He was a clinical psychologist, and he made this surprising discovery. He wrote what he called this disturbing little book about this discovery, that something like a 5 or 10 factor regression model, forget deep learning, a regression model with 5 or 10 variables would outperform a professional clinician at diagnosing schizophrenia. And he said, what? And he started testing dozens of similar situations, like graduate school admissions, hiring, medical diagnosis in other domains, what's going to be the right vintage of wine. The book and the movie Moneyball was about this, about clinical versus actuarial judgment. My original work at Deloitte was clinical versus actuarial judgment. I would build underwriting models to help underwriters better select and price complex risks. And what I found was that even, we started with neural net models, ironically, and we gave it up because it didn't make a difference. Just the linear regression models that underwriters could understand and wrap their heads around, that were trained to use well. If our underwriters use those algorithms properly, the companies they work for would save millions of dollars a year. So in 1978, Meehl wrote, there's never been a discovery in social sciences that's stronger than this. It's time to draw a practical conclusion. we haven't found a case where the clinician is better than the algorithm, and usually the algorithm outperforms the clinician. And Daniel Kahneman, and Tversky and all these others, I think have shed light on this. They realize it's not just that we satisfy, like Herbert Simon was saying. Sure, we use rules of thumb, we use heuristics to make decisions. What they discovered is those heuristics are systematically biased. So if I'm an insurance underwriter and I just am in a bad mood, well, that's noise, not bias. But if I see that, oh my God, this kitchen in this company that I might insure, this kitchen in this restaurant that I might sell insurance to, they have a deep fat fryer that's similar to the deep fat fryer that I just underwrote 6 months ago, and they had this horrible fire. Ooh, I'm not going to sell these guys insurance. Well, you're not. That's not the right beta parameter in the regression model. You're using the availability heuristic, right? You're kind of estimating a probability based on easily the scenario comes to mind. It's a trivial example, but the millions of dollars are lost. So this is why Richard Thaler became so obsessed with Moneyball. These inefficient markets persist, right? Because people are using gut feel rather than a careful assessment of evidence to make decisions. They're thinking fast when they think they're thinking slow and they're not. And so it's the same, and so there are ethical dimensions to this too. A lot of people say it's unethical to use algorithms to make decisions in these fraught cases, like hiring jurisprudence medicine. But if this is true, that the human mind is biased in these ways, and our decisions are noisy, and you all know Kahneman's writing this new book on noise. Then maybe there are ethical implications to refusing to consider using algorithms in cases like this. So the bottom line is that algorithms can reckon, they can weigh variables together better than the human mind can. We have a hard time weighing 5 variables together and doing it consistently before lunch versus after lunch when we're sleepy. Algorithms can weigh 500 variables together, ideally in a statistically optimal way that kind of like make the ethical trade-offs in a way that can be documented and deliberated at a societal level and investigated by journalists. And that's all really, really good. Unlike the human brain, which is a true noisy black box. Okay, so there are reasons to consider using algorithms in these situations. But the article ended with a beautiful, beautiful comment by Darnell Gates, the guy pictured here, who was actually on parole. He was granted parole. So he was on the receiving end of one of these algorithms. He said, does a computer know that I might have to go to the doctor's appointment on Friday at 2 o'clock, so I can't visit the probation office? How's it going to understand me as it's dictating everything I have to do? I can't explain my situation to a computer, but I can sit here and interact with you. And you can see my expressions of what I'm going through right now. Honestly, when I read that, at the very end of that article, I was thinking of a new book that came out by Brian Cantwell Smith, another former Casmus fellow here in the early 80s. He's a computer science professor at Toronto, and he's also a kind of a philosopher. This book is really a philosophy book that looks like a computer science book. I can tell you more about that during Q&A if you're interested. Bottom line, look at the subtitle, Reckoning and Judgment. Brian Cantwell Smith is saying, yes, I agree with Paul Meehl, I agree with Daniel Kahneman, I agree with Sendhil Mullainathan. Algorithms can reckon better than humans can, but they can't judge. Judgment requires not only registering the world, but doing in ways that are appropriate to the circumstances. That's an incredibly high bar. So when I'm a data scientist and I'm working with Richard Burke or working with some expert judge, and I'm saying, wait, what should I predict? Should I predict whether the person's going to recidivate within 6 months, 3 months? What does recidivate mean? What about these edge cases? This is a noisy outcome variable. What about these predictive variables? Prior arrest, that means something different for Black people than white people. What about that? These are all ways of registering the world. There are just like so many scientific and ethical judgment calls when we decide not only what variables to use, how to measure ambiguous quantities. Is gender binary, or should it have three categories? I used to joke about that early on when you'd say male, female, other, a long time ago. Now I realize, well, I shouldn't joke about that, right? There's so many cases that we're just kind of blind to, because you all know about the attention is like a spotlight. If you're watching how many times the basketball changes hands, some guy in a gorilla suit can walk across the stage and you don't even notice him. That's my analogy for a data scientist when he or she is working on these really complicated tasks. It's not that the data scientist is stupid or unethical or not a thoughtful person. He'd be as thoughtful as you are, or as I am under these circumstances. But in the heat of battle, your attention is focused on these technical things. It's easy to just lose sight of these ethical dimensions. Okay, that's again why we need kind of a broader notion of what data science is. So that's the paradox. Like, look, computers are better than us at some things. They're for self-driving cars, they're better at not getting tired and not getting to road rage. But we're better with self-driving cars. If I've spent my whole life driving in Palo Alto, and I'd start driving in Pondicherry for the first time, even if I've never seen a sort of food cart in the street like this, I can know to navigate around it. But a self-driving car would crash into that food cart, or it might, because it doesn't have any common sense. It can't judge, right? It can't use common sense reasoning. So there's this kind of very deep complementarity about human intelligence and machine intelligence. We need to understand both the quote unquote psychology of machines, but we also need to understand the psychology of humans. We need to understand how they can, how they're not competitors, they're complementary. Anyway, let me finish this story and then I'll go into that theme. Another kind of comment in this article that raised my attention is that these algorithms are presumably not black boxes inherently, right? They're not deep learning algorithms. I presume these algorithms are essentially logistic regression models where the variable importance ranking and the variables can be documented. You can get reason messages. I've done all this kind of stuff. What fascinated me was that the most commonly used algorithms, the variables being used are trade secrets. So the judge doesn't know what the variables are. So let's set aside and the issues about justice and fairness and so on. Very deep conversation. This is a more elementary point that I'm making here. If algorithmic outputs can be used by judges so the judges can make less biased, less noisy, more efficient decisions. But if the judge doesn't understand the technology, how can he or she use it properly? Going back to Don Norman, if you've read Design of Everyday Things, you'll remember this. I'm sure you all know this, right? There's this simple thing, right? If you have two knobs, one for freezer, one for refrigerating, you tune it right, your ice cream's going to melt because you don't really understand, you don't have a good conceptual model of the technology, right? Really, one of the knobs, the one that's labeled freezer, really is about how much heat is taken away from the whole unit. And the other, the one labeled refrigerator, distributes the heat from the two chambers. So it's not what you thought it meant. So if you don't have a good conceptual model of the technology, what those two knobs mean, you're going to melt your ice cream. If you don't have a good conceptual model of the Tesla car, you're going to kill yourself. And if the judge doesn't have a good conceptual model of the algorithm he or she is using, you're going to get artificial stupidity, right? By analogy, early in my career, I built one of the first algorithms I built on the job at Deloitte was an underwriting algorithm for workers' comp insurance. And we were nervous that it wouldn't make accurate predictions because it was a somewhat small client. They'd never that much data. And we were new at this, and it was kind of a new application. 6 months later, they called us and said, you guys are going to be really happy to hear this, but your algorithm worked every bit as well as you thought it would. And we were like, high five, the whole thing. And then they said, but we lost money with it. And we said, why? And they said, our underwriters were using the algorithmic outputs to give discounts to good risks, but they wouldn't surcharge the bad risks. So they just collected less revenue with a good algorithm. That was a very early example of artificial stupidity. They didn't work with us to do the implementation, but the point is that handoff between the machine and the human, that wasn't quite right. And I call that the dark matter of AI. That's the sort of part of AI that's not systematized and sort of not systematically thought through. Let me go back to that earlier comment I was making, though, about the complementarity between machine and human cognition. I hope you all who know Alison Gopnik is. She's one of my heroes, a philosopher and also one of the most distinguished developmental psychologists in the world. She's at UC Berkeley, so she's Michael Jordan's colleague there. It also happens that Adam Gopnik, the New Yorker writer, is her brother. So she must have been, the good writing must be inherited in the family somehow. This is one of my favorite quotes of all times. So I'll just read it. She said, one of the fascinating things about the search for AI is that it's been so hard to predict which parts would be easy or hard, or which would be hard. At first, we thought that the quintessential preoccupations of the officially smart few, like playing chess or proving theorems, the bullfights of nerd machismo, would prove to be the hardest for computers. But in fact, they turn out to be easy. The things any dummy can do, like recognizing objects or picking them up, those are much harder. And it turns out to be much easier to simulate the reasoning of a highly trained adult expert than to mimic the ordinary reasoning of every baby. So a highly trained adult expert would be a judge that has to go to law school. And the judge was insulted by this thought that a simple regression model can outperform him. Or Philip Seymour Hoffman in Moneyball was like, no way. And there's this whole thing that Cade Massey and so on are doing on algorithm aversion, right? But just common sense. Somebody watching the news would say, come on, the judge is not taking into account this really important common sense thing right here. So that's the complementarity that Alison Gopnik's talking about. And remember the master narrative. Herb Simon built a theorem proving thing, right? Garry Kasparov beaten by Deep Blue. Everybody assumes that once we can beat Lee Sedol, computers are going to kind of wake up, become smart tomorrow. And she's saying that's the one thing we've learned since 1956 is it doesn't work that way. It's easier to do those things that are hard for us, but it's really hard to get computers to do things that are easy for us. So the hard problems are easy and the easy problems are hard. And that's called Moravec's paradox, or sometimes the AI paradox. I'll just let you read all this kind of stuff, but I think this distinction between judgment and reckoning is an example of that, right? Algorithms are good at doing those things that Kahneman and Tversky warn us that we're bad at. but we're good at using common sense reasoning. And getting computers to use common sense reasoning has been the huge goal of AI all these years, and no one has cracked it. And it's just not really on the horizon, you know. So the implications of this is that it's not what Jeff Hinton was suggesting. It's not the case that algorithms should replace the radiologist or the judge. The fundamental design principles, like if you've got like whenever you're on the job and if you have two people with complementary skills, like Sarah Kovar and I have very complementary skills, and Sarah and I work really well together. When Sarah Kovar and I are on a team, we transcend each other's relative strengths and limitations, and we form a really smart team. And by the way, there's research suggesting that part of that might be because Sarah's a female and she has good social perception. We can talk about that later on. That's kind of the research of Anita Woolley and Tom Malone. But so we should begin, the fundamental design principle is that we should begin with the assumption of the need for human machine partnerships. And that requires human-centered design. Automating tasks should not be the default mode of AI design, okay? And there's a nice parable that illustrates the power of this insight. Not new with me, but to me, it's a very powerful metaphor. So remember, we talked about Gary Kasparov being beaten by Deep Blue. Hey, it's the brain's last stand. If we do that, computers can do anything. No, that's what Moravec's paradox teaches us is probably not gonna happen. There's a nice twist into that story. So after Kasparov was beaten by the computer, he invented a new game of chess called advanced chess. And advanced chess would be, instead of Jim playing Sarah at chess, it could be Jim using a computer playing against Sarah using a computer. And maybe Sarah's a better chess player than Jim, but Jim using a computer might beat Sarah using a computer. And indeed, Gary Kasparov found that he was not as good at advanced chess as he had been at regular classical chess. Why? I think the reason was probably that Gary, to be a chess grandmaster, you have to be really good, kind of unusually good at memorizing chess patterns. That's something that's very hard for the human mind, but guess what? Very easy for computers. So once you give the players computers to use, it kind of levels the playing field. Well, this really kind of came to a head in 2005 when there was a global online competition of advanced chess called freestyle chess. And there was an upset victory. These guys won. 2 amateur chess players from New Hampshire using 3 ordinary laptops, each equipped with a different chess program. They beat grandmasters like Kasparov using some of the best computers of the day. 5 years later, Kasparov wrote about this. He said that Zach and Steven's skill at manipulating and, quote, coaching their computers to look deeply into positions counteracted the superior chess understanding of their grandmaster opponents and the greater computational power of the other participants. So a weak human and a machine, but a better process of working together, was superior to a strong computer alone, and more remarkably superior to a strong human machine, an inferior process. So in my underwriting example, the process was wrong and they got artificial stupidity, right? And it's in the Tesla example, the process of human machine collaboration was wrong. The guy killed himself. In that recidivism algorithm, again, the process wasn't being set up right. I mean, Richard Burke is a brilliant statistician, but like somehow it was kind of like the you know, it wasn't his fault, no more than it was my fault that the client was misusing our algorithm. But the field of this kind of human computer collaboration was narrowly framed in such a way that these important considerations kind of fall through the cracks. So great AI is about more than optimizing algorithms. Like there's a science of optimizing algorithms. It's called machine learning or classical statistics. You maximize likelihoods, but there's no real science of optimizing a process of human machine collaboration, or at least it's something that's being developed, I guess. So statistics and computer science are an incomplete conceptual foundation for what we need. We also need training and education, ideas from ethics, psychology, human-centered design, behavioral economics, and so on. That's been kind of my learning over the years. Okay, this is not an old idea. It goes back to J.C.R. Licklider, who inspired Douglas Engelbart, who's Steve Jobs about the mouse from, you know, computers are a bicycle for the mind, right? Barbara Grosz at Harvard, right? She says it's not enough for AI systems to be smart. They both need to be smart and they need to be good teammates. And she's literally, you know, explicitly telegraphing J.C.R. Licklider, the guy who wrote the original sort of human computer symbiosis manifesto back in 1960. Okay, so that's a better way of thinking about artificial intelligence. AI really is the extended intelligence, the kind of group intelligence that emerges from humans and machines working together. Like in the case of freestyle chess, that was just like me and Sarah forming a smart team. Well, Zach, Steven, and those 3 computers were a collective intelligence that beat the collective intelligence formed by grandmasters and supercomputers. Okay. All right, let me just give one last example. I'm going to try to do it in about 3 minutes, and then I'll be on time. Maybe I'll go 1 minute over. So that was a thinking slow story, right? We want rational deliberation, judges thinking it through, going to weigh all these variables together. I'm going to make this call. What are the odds if I release this person? He will, commit another crime and recidivate. I'm going to give another example. And Sarah's Kovar has heard me give this example maybe about 78 times. So sorry, Sarah, it's going to be the 79th time this time. So don't fall asleep. All right. So, maybe a decade ago, I was inspired to think that, whoa, there's this new thing called nudge. It's this kind of spin-off of behavioral economics. Oh my God, really? Nudge is not a book of behavioral economics, by the way. I think you guys all know that, right? It's really a book about psychology. It's really a book about human-centered design. And I was fascinated when I read in Thaler's memoirs that he said that when he and Sunstein were sitting down to write the book Nudge. By the way, Thaler was here with George Lowenstein at Caspis in the late 90s. That's where all these ideas started percolating. They were missing the organizing principle, and he had this breakthrough when he read Norman's book, The Design of Everyday Things. And by the way, I have a screenshot of my computer when I quoted Thaler. We're capable of recognizing. The computer is nudging me to improve Thaler's grammar, saying we can, we should replace that with could recognize. So Thaler, you live by the nudge, you die by the nudge. But the point is that Nudge is a book about human-centered design. Ironically, I think the framing of it might be a bit counterproductive. I have some libertarian friends. Yes, some of my best friends are libertarians, and they hate this stuff because like, why would you want paternalism, right? But really, what I describe it is human-centered design for choice environments to help us navigate complex environments like choosing insurance deductibles. They're like, well, who would object to that? So that's really the way I think about it. I just think it as being a kind of like a sequel to Don Norman's book, The Design of Everyday Things, for choice environments. Makes sense, right? Now, the reason my friend Lavan Srinivarianadas forwarded me this article is because there's another story in it about a welfare model in Rotterdam in the Netherlands that was used to flag people who might be committing welfare fraud. And it kind of flagged entire neighborhoods of people en masse, and they're all being investigated, and it's a weapon of mass destruction and so on and so on. Well, Lavan forwarded me this article because he said, Jim, isn't this similar to your New Mexico study? And well, yeah, it was. Many years ago, this is, I think, before I started working with Sarah, but this is kind of how Sarah and I kind of got to know each other. We were hired to build a fraud detection model for the state of New Mexico to flag people collecting unemployment insurance benefits who are suspected of collecting them improperly. So this pay and chase is kind of common paradigm where if later on downstream we realized people were collecting benefits improperly, they're kind of like lowballing their reported earnings. We try to claw these earnings back, and nobody's happy about that. So hey, can we use these smart machines to kind of flag people in real time who are suspected of collecting benefits improperly? Now, we were initially framing this the way any data scientist would, as a classification problem, right? This classification, this regression. In principle, it's like flagging cat and dog photos on the internet, right? And that's literally what we were doing. I was on the phone with some of my colleagues, and we're trying to brainstorm what is the best way to create an ensemble of machine learning techniques to most accurately flag people collecting benefits improperly, because we don't want false positives. And that got me thinking, the overall, remember the base rate fallacy? The overall base rate of recidivism, the overall base rate of improper payments is actually quite low. It's only like 5%. The implication is that even if we build like this kind of superhuman, brilliant, Gary Kasparov, deep mind level classifier, you all know Bayes' theorem, the posterior probability would not be that high, right? It wouldn't be like, if you're in the worst decile, instead of having a 1 in 20 chance of being a fraudster, maybe it's a 1 in 3 chance. But that means that if you just use an algorithm like this to shut off benefits for the riskiest people, you're gonna be wrong 2/3 of the time. So I was literally thinking to myself, oh my God, if we deploy this, we're going to be creating a weapon of mass destruction. Even though the algorithm will be good, it'll be another kind of artificial stupidity. So I was remembering some of Dan Ariely's stuff in some of his pop books, and also he wrote a book with Nina Bazar. I think I was remembering that too. Like the ice behind the coffee machine, these little kind of like situational factors you can introduce that will nudge people to act more honestly, right? So we all know, we're all kind of sophisticated psychologists here, right? We know it's not like cat and dog photos. We know that really everybody is honest or dishonest, more or less, based on the situation they're on, not just the people. We're all more or less dishonest, right? That's the honest truth about dishonesty. But contextual factors matter, okay? Like the ice behind the coffee machine. If you don't know that story, I'll tell it to you during Q&A. We A/B tested online a lot of pop-up messages, only for the people who are flagged as being potentially, suspicious of collecting benefits improperly. So if the first time in several weeks, something about the way you're reporting your earnings online trips off the algorithm, right? Maybe it's on a Saturday and it's like more money, but it's still not that much more. And they're like, wait a minute, this is suspicious. You see a little message for the first time saying, Jim, did you know that 9 out of 10 of your neighbors in Bernalillo County report their earnings accurately? This is the famous, Cialdini-style norm nudge that Thaler advised the UK behavioral insights team to use. We used a lot of other nudges that, by the way, didn't replicate for us. And we can talk about that during Q&A too. That nudge that was kind of super powered and timed and tailored using machine learning reduced improper payments by 40%. And I suspect that the large effect size was partly due to the fact that it was really kind of timed, right? The timing is important, we all know that. And it was like only for the people really suspected of it, okay? And so that was a real slam dunk. And in the midst of this, we learned about another state that built an analogous algorithm, not the Rotterdam thing, but another US state. And they still have a class action lawsuit against them because they used it to essentially shut off benefits. So again, this is another notion, another way in which AI is narrowly framed. And again, it's the kind of human interface that's sort of neglected. We always focus on predictions, but we also need to focus on interventions. And if you're a classical economist, what are interventions? Well, I was listening to a Steve Levitt Freakonomics interview last night on on Econ Talk, and that their worldview is that it's incentives, carrot and stick incentives, or just giving people information. Those are the ways to change behavior. But if you're a nudgista like us, there's a whole expanded toolkit of interventions that can change behavior, right? Now, ethical deliberation is crucial here. I like to say that we avoided a weapon of mass destruction, right? So it had more utility. So from a utilitarian perspective, I think we were doing is good. I'm a little uncomfortable with the kind of more Kantian deontological aspects of it. We want to nudge for good, not for evil. Cambridge Analytica had the same logic as what we did. Use an algorithm to identify people, then you nudge them. But that's to manipulate them. They don't know they're being nudged. On the other hand, we publicized what we're doing early on. And John Rawls had something called the publicity principle, I think it was called, when he wrote The Theory of Justice. We can talk about that, but whether you think that our application was ethical or not, I like to argue it was. There's no clean cut. I mean, ethics is all about trade-offs. I think we navigated that trade-off well. I think few tradable trust agreed with us, but there's still this kind of thing we want to think about. We want AI is about autonomous systems ostensibly, but I think AI should really be about systems that enhance human autonomy. And I think that's exactly what Cass Sunstein writes about nudge. We want to allow people to choose not to choose, right? We want nudges that improve human autonomy and human self-determination. All right. More generally, principles of ethics and psychology belong in the design phase of AI projects, no less than principles of data collection, statistical analysis, and machine learning. And I think I went 5 minutes over. I apologize, but we have 15 minutes for questions, so I'll stop here.
That was amazing. Thank you so much, Jim. I had never heard about the refrigerator and freezer analogy. I think that's fantastic because my things always are either too cold or not cold enough. So we have a lot of great questions in the Q&A box. So folks, if you want to ask a question, please put it in the Q&A part and not in the chat. So one of the questions that we have is in regard to what public messaging approaches are most effective in encouraging / nudging people to educate themselves on AI in an effort to assuage instinctual fear of replacement, which is a popular narrative going on in the future of work.
Wow, what an interesting question. I don't think I've ever quite gotten that question. I don't know if I can really answer, but I'll just give like one story from my back pages. This is sort of like while I was thinking about Kahneman and Tversky, but I hadn't quite internalized it yet. By the way, I have like quadruple imposter syndrome here, guys. I'm a self-taught data scientist. I'm like a behavioral science wannabe, so I'm not an expert, right? I've just kind of taught myself some stuff. But early on, I was on a call once, at work, and I was explaining to somebody like the premise of what we're doing with these predictive models. I said, look, don't think about these algorithms as replacing you. It's like my eyes are myopic. I can't see very well. So I have these glasses and I can see better. Well, Daniel Kahneman teaches us that, we have these bias heuristics. So metaphorically speaking, our brains are myopic and algorithms are like eyeglasses for the mind's eye. They're these tools, these kind of cognitive prostheses that help us, make better judgments and decisions. And, I really feel like that had an impact. And many years later, not even many, a couple of years later, I was working on a child support enforcement algorithm in the state of Pennsylvania. We could talk about that too. And I was trying to explain the premise of it. This is unfortunately before I started thinking about nudge. I think nudge would be an amazing toolkit for an application like that. We're just basically kind of like, giving child support enforcement underwriters algorithms that they could use to kind of prioritize their caseload. They could, like, rather than react to people after they default their payments, you can like look at people who are at risk of falling behind and proactively help coach them to stay on top of their payments so that the bad thing doesn't happen. And I said, look, yeah, I use that kind of eyeglasses for the mind metaphor. And I was speaking at a kind of a child support enforcement conference, and I could just see their eyes light up when I gave that metaphor. And then one of the kind of more senior, person who, people who's no longer in the field, she kind of like said during the Q&A, it's like, I would have loved to have had a tool like this when I was in the field. It would have made my job so much more meaningful. And that's really the whole idea of this, is that we want to deploy AI technologies in ways that make jobs more meaningful for people so they can create more value, both in the public sector, but also in private sector. But it really, honestly, it depends on trustworthiness, right? This whole idea of trustworthiness. Do you trust the people who built the algorithm, and do you trust the people who are deploying it? It's kind of like, if I work for one company and I'm a call center operator, and I really trust my employer and they're rolling out all these chatbots, I might not fear that I'm going to be replaced by the chatbot, because you can actually deploy chatbots alongside human call center operators in a way that makes the job much more fun and creates much more customer value. And that would just be like just an autopilot thing. The chatbots handle 90% of these boring calls. Is my flight on time? What's my balance? Whatever. And the human does the more interesting calls, like, oh my God, I missed my flight. I need to get home. Like, what do I do? Let that person handle that call with empathy. Oh my God, I've been there. I know that airport. Yeah, here's what you do. Even if you can't give them an answer, just that empathy is going to make people feel better, right? We all know that cognitive is effective. Now, if I'm a call center operator and I trust the judgment of my leaders that they kind of understand this, then maybe I'm okay. If I don't, then yeah, I mean, like all these tools can be used in really perverse ways. And there's this kind of like automation replacement narrative. What can I say? I don't have a global answer to this. The real challenge, at this higher level, is to convince the people that lead the businesses, those people that go to Davos, that we don't want algorithms to replace 90% of their workforce. We want to figure, sure, some jobs will go away, but we really want to figure out the right mix. Some jobs will go away, some there'll be some new jobs. Other jobs like radiology will be transformed. We don't want Jeff Hinton, well, I'm sorry if I'm being too outspoken here, but we don't want this idea that we can replace these incredibly important professionals with algorithms. You don't want to define down these professions. You want to kind of define them up using AI. That was more of a rant than an answer, so I hope that was at least an edifying rant.
That was great. And I have a related question in the chat as well from Paul. He says, thank you so much for this incredible talk. Have you thought about how the role of behavioral science and AI would translate into practice? Namely, what are the implications of AI to user experience or user interfaces?
Very interesting. Yeah. Again, I don't have a global answer, but I think that right now it's like I feel like either behavioral insights for the sort of like human interface thing, it's either sort of neglected, or if it's used at all, it's used in an unethical way. So it's really like, I like to say that AI should be designed to go with the grain of human psychology, right? So we want an algorithm that the judge can wrap his or her head around and really use it to make himself smarter, right? Just like we have the eyeglasses that fit my head, and that's not really being done very well. So we need AI that's explainable, but we also need to kind of train the judge to understand the premises of it, right? To understand that really it's an eyeglass for the mind. We need to have the judge understand what the knobs in the refrigerator are, metaphorically speaking. The only places where it's being used, the notable cases where psychology is used is cases like Cambridge Analytica, or cases like, oh, we'll do the like button. There's this whole field called persuasive technology. Do you guys know about this? It was invented here at Stanford. And the guy who leads the persuasive technology lab, he's called the millionaire maker, the billionaire maker. He's been hugely influential in Silicon Valley. So, all these things you hear about on these documentaries like The Social Dilemma about technologies that addict us. We want to kind of like design our algorithms to kind of like, give you more and more sort of incendiary material, or more material that kind of punches your emotional buttons, right? We all know that we have these different systems. We have cognitive, behavioral, but also affective, right? And like, reason is a slave to the passions. And we all know, like even smart people, their emotions can be tapped into, the smartest people. And we're consciously designing a technology to kind of like glue ourselves to the screens. And so that's a case where psychology is being used, but it's being used to addict people. And so like we're sort of at the stage in AI where design was before a failure road nudge. It's kind of like we want to take the same toolkit that's often used by advertising type people to get them to do things, to manipulate them basically. Let's use it in ways that get people to extend their intelligence, overcome their bounded behavior, and tap into their bounded self-interest. And so, I gave the New Mexico example as one example. Another example would be in child support. We have these algorithms that flag people who might fall behind their benefits. What if we can use financial health coaches? What if we can use like pre-commitment devices? What if we can use smart defaults, apps like apps along the lines of Shlomo Benartzi's Acorns app that help people save more so they don't fall behind their child support payments? So I call this the last mile problem of data science, right? Again, data scientists always think, oh, it's about the prediction. I have this great algorithm that makes accurate predictions. But the last mile is we don't care about algorithmic outputs. We care about better outcomes. Sure, it's great that I flag this person might fall behind, but the real win is when that person doesn't fall behind, and that's where we need the nudges. Okay, so it's like for algorithms to help that flag people who are unhealthy, algorithms that help people who aren't saving enough, algorithms that are used for people that could donate but that aren't donating. So why not an algorithm together with like a donate more tomorrow instead of save more tomorrow? The sky's the limit. It's just we haven't started thinking through the implications of this.
That's great. The output versus outcome, I think, is really important as folks are thinking about how to design for a better world.
Can I give you another example, just real quick?
Go for it.
You know this one, Sarah. Dan Goldstein at Microsoft Research. He's a Gerd Gigerenzer student. I hope Gigerenzer is okay for me to mention him. I know that there's some bad blood between him and Thaler, but brilliant people, all of these people. But Goldstein works at Microsoft, so he put some AI algorithms into the Bing search engine. So if you do a Google search on what is the area of Poland, you will get back, this is how many square feet it is. And those big numbers mean essentially nothing to me as a boundedly rational human. If I do the search in Bing, I get that same number, but also, it's about the same size as Utah, because I'm an American, so I know about how big. So I have another mental model of how big Utah is. Again, that's another aspect of human-centered design. The outcome is me being able to achieve my goal, which is, I want to know how many days should I spend in Poland, or how many days should I spend, driving around, kind of thing. That less accurate information is more useful to me as a human than the more accurate number. So that's, again, designing for the brains of humans, not of Vulcans. Again, it's a gem with many facets, this idea of human centricity.
That's wonderful. And we have in the chat from Fernanda, thank you so much for the great presentation. Could you mention other studies where and how governments are or are not using AI? And what are the most common areas in which this is being used?
Just for AI, not the nudge thing. Well,
and together with the nudge thing.
Yeah. I think that in general, I think that there's like a lot. Well, like facial recognition is a hugely fraught topic right now, right? And that documentary with Joy Buolamwini, I think will shed a lot of light on that. I haven't seen it yet, but she did some kind of landmark research, kind of showing there's bias in like the great majority of commercial facial recognition software. So I think that study was influential in some of these major companies issuing a moratorium on police use of these facial recognition technologies. But I think that the experience I've had is less technically fancy. It's more kind of along the lines of the recidivism algorithms or the child support enforcement algorithms. I guess that the New Mexico thing, that was more of like a true machine learning algorithm. In full disclosure, my colleague Mike Green, brilliant guy, built that, not me. But yeah, I think that overall, the gist of these algorithms is it's being used to flag people. So that Rotterdam story, about how we built this algorithm, and it flags people, who are suspected of committing welfare fraud. I think the problem is that we're just focused on the algorithm, but not enough about the kind of, as I say, not about the interventions. So I don't know if I'm giving a really great answer to your question, but basically the kind of like Moneyball way I think about this is that anytime you have a human judge who's kind of repeatedly making these kind of judgment calls about what do I do? Should I inspect this building? Should I reach out to this, non-custodial parent? Is this person going to recidivate? Is this student likely to drop out of high school? Like another great example of this last mile idea would be, you can build an algorithm to flag which kids are likely to drop out of high school. And there's a great study that Sendil Mullainathan at Chicago was involved in about how an after-school program called Becoming a Man, which was premised on cognitive behavioral therapy, that reduced dropouts by like 40%. You know, it went away after the program ended, but still, while the program was going, it had a real effect. You know, Rad Ghani, I'll just leave you that with that name. Rad Ghani at Carnegie Mellon used to be at Chicago. He leads a data science for social good group. Look up his website. He just has any number of examples of machine learning for public sector, public good kind of stuff. Flagging, you know, houses where children are at risk of lead paint poisoning, and you can imagine the nudges it would take to kind of get you know, the head of the household to kind of ameliorate the situation, or, you know, or the public sector people. Anyway, I'll leave it there. Just tons of examples. Just think in terms of Moneyball. You know, when humans are making decisions, we can give them these cognitive prostheses, make these people, you know, we can help them make better judgment calls about who to reach out to. Then nudges tell us how to address the situation.
Yeah, and that softer encouragement or applying nudges to areas where we aren't sure whether or not our model is being super accurate is a lot more helpful than just taking away people's benefits.
Very good. That's exactly right. A lot of evidence are ambiguous. There's either epistemic ambiguity, like, you know, there's just a lot of uncertainty around that outcome, or there's just like inherent ambiguity in the world. What does fraud mean? It's like it's an edge case. Is this building safe or unsafe? Well, if it's a really bad building, you push the worst. You send the inspector out to the building. But if it's a building kind of in the middle of the spectrum, you don't have time to investigate all those buildings, nor do you want to hassle people. So that's where the nudges is more useful. Thanks, Sarah. That's a really good comment.
Of course. And we have one more minute. So in quick closing question, we have someone asking, how do we encourage data scientists to adopt this more human-centered AI?
For me, it's all carrot and sticks. You just punish them if they don't do it. No, I'm kidding. You know, honestly, I think, you know, Nick Epley has this really nice thing on treating ethics as a design problem. He talks about kind of attention, construal, and motivation. And, you know, again, attention's like a spotlight. I was kind of thinking about Nick Epley's paper when I said that earlier. You know, in the heat of, you know, so they're already motivated. They want to do this, right? And maybe getting more diversity in data science. If the current data scientists are not intrinsically motivated to do this kind of stuff, then maybe we need to hire like a broader type of data scientist. We do need people who are just going to like geek out on tuning hyperparameters, but we need this broader notion of data scientists. So we need data scientists who are intrinsically motivated to do this. Once they're intrinsically motivated to kind of like have kind of a broader, you know, kind of human-centered perspective on data science, you know, we need to kind of prompt them to construe the situation in a way that would kind of get them to you know, kind of like think through the design elements, both in the creating the data set on the first mile problem, but also on the human integration on the last mile problem. And then attention, we need to kind of like maybe nudge them along the way during their workflow. And there are already software platforms like Data Robot and like I think Einstein by Salesforce, they have little nudges along the way saying, hey, you know, this variable might be a proxy for something else. Think about this, you know. So attention, control, motivation, those, you know, maybe we can use the behavioral insights toolkit. How's that? I just made that up, but I think it makes sense.
That's wonderful. Well, thank you, Jim and Sarah, for this wonderful conversation today. I just wanted to let everybody know that the recording will be available on our Twitter page at Harvard BIG. And with that, we're closing and we are going to see you at our next big webinar. Thank you all so much. And thank you again, James and Sarah. Appreciate it.
Thanks, a lot of fun. Thanks, Sarah. Thanks, Margaret.
Thank you so much, Jim.